Hi all, for Year 10 5.3 Properties of Geometrical Figures, our second lesson is on deductive reasoning using triangles. So we already know many geometrical facts concerning triangles, and we learnt quite a lot about angles last lesson. What we know about triangles is that the angle sum of a triangle adds to 180. So in any triangle, the sum adds to 180. So if we look at our triangle over here, this one right here, what we know about this triangle is that it wants to add to 180. So we have 100 degrees plus 50 degrees plus 30 degrees, which equals 180 degrees. So this means that this shape is a triangle. But we have different type of triangles and triangle properties. So our first type of triangle that we're going to look at today is an isosceles triangle. So isosceles triangles have two equal sides, this one and this one here. They have two equal angles, this one and this one down here, and they have one axis of symmetry. So when I talk about the axis of symmetry, it means that we draw a straight line through it, and the left side is exactly the same as the right side. So that's what we know about isosceles triangles. And we can use these properties of isosceles triangles to prove things when we are trying to find unknown angles or unknown sides. Equilateral triangles. So if we look at our equilateral triangles, they have three equal sides. So this one, and this one. And they have three equal angles, this one, and this one. So how we can work out what the value of these angles is we can go 180 divided by 3 because there's three angles. So that means that equilateral triangles, all their angles have to equal 60 degrees because 180 divided by 3 is 60 degrees. And they also have three axes of symmetry. So my first axis of symmetry would be drawing it down the middle, drawing it this way, and drawing it this way are my axis of symmetry. Roughly, my sketching's not the best there. Moving on, we have the exterior angle of a triangle and the properties we know about the exterior angle of the triangle. So the exterior angle of the triangle is equal to the sum of the two interior opposite angles. So that means that these angles, this angle here, our exterior angle, is equal to A, alpha, and beta. So that means that alpha plus beta, which is our outside, is equal to alpha plus beta. So we are going to use the angle sum of a triangle, the properties of an isosceles triangle, the properties of equilateral triangles, and the exterior angle of a triangle, plus what we know about angles and parallel lines to solve these examples and to do exercise 301B from our textbook. So for example 1, we have that AB is parallel to CE, and we want to find the size of X. So we have that AB is parallel to CD. So I am going CE, and just draw along my parallel lines like so. Okay, and we're trying to find X. So we have been given that this is 50 degrees up here. So we have been given, our information we have been given is that angle BAD equals 50 degrees. We've also been given that angle FCD equals 55 degrees. So what we are going to do to solve this is that we have highlighted our parallel lines, but if we highlight our line AD here, we can see that we have made a Z shape. When we make a Z shape with parallel lines, we're talking about alternate angles, and we're talking about how alternate angles are equal. So that means that our 50 degrees here is going to be 50 degrees in our triangle here. So that means that we have that angle BAD equals angle FDC, which equals our 50 degrees. Now looking at our shape, we have our triangle here, and we have two angles and one unknown. So using the property angle sum of a triangle, we can find our x degrees. So we know that the angle sum of a triangle adds to be 180 degrees. Oh, and going back to our angle BAD equals angle FDC equals 50 degrees, we have to write a reason. And our reason for that was alternate angles. So alt angles and parallel lines, which is AB is parallel to CE. So using what we know about our triangles and the angle sum of triangle equals 180 degrees, what we do is x equals 180 minus our two angles. So minus our 50 degrees and minus our 55 degrees. So when we go 180 minus 50 minus 55 degrees, what we get is 180 minus 105 degrees, which equals 75 degrees. So therefore, our x would equal 75. And our reason for this will be because of angle sum of triangle. And that's all we have to write as our reason. For example 2, we have to find the size of angle BCA. So if we look at our shape, we're trying to find angle BCA. And you will notice about angle BCA is that it is an exterior angle, and we are given the two interior angles of our triangle. So we're going to use what we know about exterior angles in order to find angle BCA. So what we know about angle BCA is that we are going to add our two interior angles together to get our exterior angle. So angle BCA will equal 82 degrees plus 55 degrees. So when we add these together, we get angle BCA equals 137 degrees. And our reasoning for that is because of exterior angle of triangle. So that was nice and straightforward. For example 3, we want to find the value of, it's meant to be y, of y. Okay, so we have that our y is this angle here, and we can note about our triangle is that it is an isosceles triangle because we have the labels on each side saying that these sides are equal to one another. However, we need to find out what the angles of the isosceles triangle are first so that we can find out our angle y. So what we are going to do for this example is we first need to find angle ACB. Now angle ACB will equal 180 minus 110 degrees, or how we got the 110 degrees was from angle ACD, angle ACD. So it's 180 minus 110, so we get 70 degrees. So that means that angle ACB is going to equal 70 degrees. And the reasoning for this is because we have adjacent angles next to each other. Adjacent angles are supplementary. So we actually call this adjacent supplementary angles, where supplementary means add to 180. So our two angles, ACB and ACD, add to 180 degrees to get the angle ACB equals 70 degrees. Because angle ACB equals 70 degrees, we can therefore say that angle ABC equals 70 degrees also because of isosceles triangles. So we write that it's the base angles of isosceles triangles. as our reasoning when we're talking about isosceles triangles. Finally, to find our y angle, what we're going to do is say that y equals our 180 minus our angle ABC and minus our other angle in our triangle, which is angle ACB. So that means that y equals 180 minus, I think I just zoomed out a bit there, minus 70 degrees minus 70 degrees. So y equals 180 minus 70 equals 40 degrees. And so our reasoning behind that is because angle sum of a triangle. So we write angle sum of triangle. If you are in my Year 10 maths class, what you should complete now is have a go at doing exercise 301B, question 1 to 5. And this is on page just 58